Hello and welcome to 4.4 Video Notes. This is going to start on page 295, and here we're going to read through this example. It says the Lockheed SR-771 Blackbird has a top speed of 36.6 miles per minute. If x represents the minutes traveled at this speed, the function rule for this distance traveled is y equals 36.6x. So as you can see here, we have this table, and this isn't all the way filled in for you guys, so you can ignore my typing here. So what I did was I went through and I filled these in. See the input, which we know is our x value. We have 1, 2, 3, and 4. Our rule, which is really just the equation they gave us, is 36.6 times x. Our output is y, and then we have input output here. And really this is just asking what is the ordered pair. And so if we look at the first column, we'll go ahead and do the second one. We can look back at the first one for an example. We have the input of 2, so 36.6 times 2. And that gives me a total of 73.2. So I can type that in here. Make sure you have that filled in your chart. And then if I want to put that into an ordered pair, I put the x value first, which is 2, and then the y value, which was the output, 73.2. Now for 3, I'm going to end up doing 36.6 times 3, which gives me 109.8. And I have an ordered pair that's going to look like 3, 109.8. Now for the last one, if it's going for 4 minutes, we're doing 36.6 times 4, which gives me 146.4, and this is what the ordered pair looks like. Now on number 2, it asked me to graph them, so I'm going to go ahead and quickly graph, and I already have these labeled, and the reason I know that x represents number of minutes is because my input up here, I'm going 1, 2, 3, 4. Well, those numbers are all of the minutes. Now the output y, the 36.6, 73.2, and so on, those are my distance traveled. So I'm going to end up using these ordered pairs to make my graph. So I'm going to start by doing 1 36.6, and this will be estimating since we have the decimals and such, and it's not counting exactly by 1, so it's not going to be the most accurate. But the next one I go over 2 up 73.2, and then over 3 up 109.8. And then I go over 4 up 146.4. All right, and the question actually says here, what do you notice about the graph? One of the biggest things that I notice is it appears to be in a straight line, which hopefully by now we remember that that means it is linear. So what do I notice about this graph? It looks like it is in a straight line here. All right, go ahead and turn the page so you're at the top of 296. It says graph a function. Sometimes functions are written using 2 variables. One variable, usually x, represents the domain, and the other, usually y, represents the range. When it's written in a form, it is an equation. Like equations, functions can be represented in words, tables, graphs, ordered pairs. So we're going to be looking at kind of graphing different functions, and the easiest way to do that is to set up a table like this one right here. So this is example 1 on page 296. That says the school store sells book covers for $2 each and notebooks for $1. Tony has $5 to spend. The function y equals 5 minus 2x represents the number of book covers x and notebooks y she can buy. Graph the function and interpret the point. So I always would start with a graph like this. I'm sorry, a table like this. Now, one thing you guys are going to question me is why aren't they doing the rule of 5 right here? Normally, I'd want you to do -2, -1, 0, 1, 2, and 1 and 2. So we have 5 values, especially a negative value. But if you think about this, a negative value could end up representing that she's buying negative amount of book covers because that's what x represents. So that doesn't make sense. You need to make sure you reread the word problem and see if negative numbers make sense. In this one, it doesn't. So we're going 0, 1, 2, and 3. And the rule, which is the equation, 5 minus 2x, everything is plugged in here. And then over here we have our output y. So if we want ordered pairs, the first ordered pair would be 0, 5. How did I get 0, 5? Well, if you look right here, my x value is 0, my y value is 5. So in order to graph that, 0 means I don't go side to side, but I go up 5. Now the next one is 1, 3, so I go over 1, up 3. And then I have 2, 1, so over 2, up 1. And then I have 3, -1, so I go over 3 and down 1. So if we want to interpret these, you can read this part underneath step 2. So this first point right here is 0, 5. that means she can buy 0 book covers and 5 notebooks. And then we go to 1, 3. She can buy 1 book cover, 3 notebooks. And then 2, 1 is 2 book covers and 1 notebook. Now this 3, 1 down here, negative 1 that is, doesn't make sense because you can't possibly buy negative of something. All right, let's do this example together. And I already kind of have this labeled for us if you want to do that so that we save a little bit of time. But the question says, the farmer's market sells apples for $2 per pound and oranges for $1 per pound. Marjorie has $10 to spend. The function y equals 10 minus 2x represents the number of apples x and oranges y Marjorie can purchase. Graph the function and interpret the points graph. Make sure you make a table first. It's going to be so much easier. And I already have this one set up for us. So I started with my x values, which I wanted to do 0, 2, and 4, mostly because I saw down here they were counting by 2s. 0, 2, 4, 6, 8, and that would just be easier to use those. So double check your graph and see if there's a easier way that you can do it. And then I plugged in to this equation. Where did I get this equation? Right up here. It gave it to me. So I'm going to be doing 10 minus 2x. This x is the values that I plug in. So instead of it being x here, it's going to be 0. So 2 times 0 is 0, and 10 minus 0 is 2. I'm sorry, 10 minus 0 is 10. Now if I plug in a 2 here, I end up doing 10 minus 4, which gives me 6. And then if I plug in a 4, 2 times 4 gives me 8, and 10 minus 2 is, sorry, 10 minus 8 is 2. So now I have some ordered pairs I can graph. The first ordered pair is 0, 10. How do I know 0, 10? I take my first x value and my first y value. So 0, 10 says that I do not go over, but I go up to 10. That's the first one. Now, after that, I have 2, 6. That tells me to go over to 2 and up to 6. After that, I have 4, 2. Tells me to go over 4, up 2. Now, we can interpret these points, and I'm just going to type them out so I don't have to try and write them. But the first point that we did was 0, 10. And it wants us to interpret them, which means what does it actually mean in real world? Because since this is a real world problem, these have representations. So if you look, 0 represents our x value, which is apples. So she's going to end up being left with 0. Sorry about that. She's going to be left with 0 pounds of apples. She can't. Try again. All right, so 0 pounds of apples. I'm going to abbreviate pounds, LBS. But that means she can get 10 pounds of oranges. Because I know this because the y values represent oranges. Now if I go to my next point, which is 2, 6, that tells me she can get 2 pounds of apples and then only 6 pounds of oranges. And then this last point here, same kind of thing. I'm over at 4 and I went up to 2. That tells me she can get 4 pounds of apples and only 2 pounds of oranges. So remember to interpret these points if you are asked. Now in this example 2, which is over on page 297, you can see here they just want you to graph this. Okay, so when you see something asking you to graph, all caps, make a table first. And then I'm even going to highlight this because if I come to see you graph it, I don't have a problem helping you, but if you haven't made a table first, I'm going to have you do that before. All right? Make a table first. How do we make a table? Start with your x. And then put in your rule. Remember, this is your rule / equation. And I'm still in caps. However you want to think about it, rule, equation, it's whatever you're actually doing. Multiplying, adding, whatever it asks you to do. Now over here is the y values. And then this last one is the ordered pairs. This will help you do the graphing part. It'll kind of take a step out. So yeah, I think you should put in this column right here. So they have gone through all of this and they have graphed it. All right. And if you really want to check, hey, is this true? You can pick an ordered pair that looks like it's on the line and then double check it. So please feel free to read through this on your own time. I want to do an example with you, which is B right here. So it says the instructions would be to graph this. How do we graph it? Well, the first thing we have to do is set up our table. And I'm going to set up our table, not with these values, but I want to do 0, 1, 2, and 3. So when I start with 0, I plug that into my equation. So instead of x minus 5, I'm going 0 minus 5. Now I can go to this next one. I can fill it in like this, 1 minus 5. You guys also know you're allowed to do lazy on your homework. That's fine. I'm writing it all out so you guys can see what I'm doing. So 0 minus 5 for y would give me a negative 5. 1 minus 5 gives me negative 4. 2 minus 5 gives me negative 3. And then 3 minus 5 gives me negative 2. Now, if you want to write that out for this first one, you can. That way you know what I'm talking about. So what are the ordered pairs? Well, I already have them written out. I just want to put them in what looks like an ordered pair. 0 comes from the x value. Negative 5 comes from the y value. So this one, I'm 1, comma, negative 4. The next one, I'm at 2, comma, negative 3. And then the last one that we can do here is going to be 3, negative 2. Make sure you get this chart filled in, this table I mean, it'll really help you. And then you actually do need to do the graphing part of it. So I start with my ordered pairs at 0, negative 5, which means I go down negative 5. 4, 5. And then this one, 1, negative 4, over 1, down 4, over 2, down 3, over 3, down 2. So here you can see that it starts to make a line, a straight line even, and we can connect our points. And that's what it looks like graphed. One more example of this. This is C on the same page, 297. And I already have the table set up here. And it looks like I already have the line in, but we'll delete that. I want to go ahead and fill in the rest of this table. So instead of negative 2 times x, I'm going to plug in negative 2 times 0. And then this next one down here is negative 2 times 1. And then I have negative 2 times 2. Where did I get all of these numbers right here? All of my x values. So this first one, negative 2 times 0, gives me 0. Negative 2 times a positive 1 gives me negative 2. Negative 2 times positive 2 gives me negative 4. My OP, or ordered pairs, for this first one is 0, comma 0, which is a special point we know is the origin. Next I have 1, comma, negative 2. And then the last one I have is 2, comma, negative 4. And the last step is going to be to graph them. And I graph them by going, okay, my ordered pairs are 0, 0. And then I have 1, negative 2. And then I have 2, negative 4. And then we connect with a line.